Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda. I'm going to teach you some algebra right now. This is lesson 7.2 on multiplying polynomials, and the title gives away the goal, the question, the objective. How do you multiply two polynomials? We looked at the previous episode and we learned what polynomials were. We learned how to add them and subtract them. Now we'll learn how to multiply them. We'll talk about multiplying binomials, this thing called the FOIL method very briefly, and then multiplying binomials and trinomials. The FOIL method is really the same as this, and we'll get into that when we get there. So multiplying polynomials is based on the same idea that any multiplying two-digit numbers, such as 27 times 34. When we have a two-digit number times a two-digit number, how many times do we actually multiply? Let's see, 7 times 4. 28. We go 8 and carry the 2, right? We're actually taking a shortcut there, but we carry the 2, but that's really a 28. Then 4 times 2 is 8, plus 2 would be 10. Okay, so I've multiplied a second time. And then I've taken care of that extra 20 from the first time. 3 times 7, this is really 30 times 7, so we go 21, right? 21, and then that's a third time we're multiplying, and then 3 times 2 is 6. 6 plus 2 is 8, and we get 918. But I actually multiplied 4 times. So what we're going to do is think about this as multiplying like this. 20 plus 7 times 30 plus 4. We'll multiply each of these things. 20 times 30 and 4, which we did, and then 7 times 30 and 7 times 4, which we did. So let's take a look at how all this factors into what we're going to do with multiplying two binomials. My first example, x plus 2 times the binomial x plus 5. Okay, I'm going to multiply the x times x. I get x squared. I'm going to multiply x times 5, I get 5x. Then I start with a 2. 2 times x, 2x. 2 times 5, 10. Then I collect like terms. Well, first of all, let me say this. We call these partial products. We're not done multiplying yet, but we've multiplied 4 times, and each of those results in what we call a partial product. Just like when we were multiplying two-digit numbers, you have all these things that you write down and then you add them up at the end, partial products. Then, collect like terms. 5x and 2x is 7x, so my final form is x squared plus 7x plus 10. Okay. For example B, x plus 3 times x plus 4. X times x, x squared. X times 4, 4x. 3 times x, 3x. 3 times 4, 12. Can I collect like terms? Yes, I have like terms here in the middle. So x squared plus 7x plus 12. Okay, so there is this example. Write down what you need to, and then we'll move on. We have a table method for multiplying binomials, and to me, this is a little too much work for something that's kind of simple, but if you need to do something like this, you can. We have a 4x4 grid because up here, I'm going to write each of the terms of the first binomial, 2x and negative 3. Down the side, x and 5. And then we multiply and we'll get our 4 partial products. X times 2x, 2x squared. X times negative 3, negative 3x. Then 2x times 5, 10x. 5 times negative 3, negative 15. And Usually, not always, you have to kind of check because you're not sure what all these different uh, terms for binomials will be. Do you have like terms? Often they are catty corner there. And then we write them in order. 2x squared. 10x minus 3x, 7x. And my constant goes last, negative 15. Okay, and that is using a table. If you want to use the table, great. If you don't want to, that's great. This is just another way to organize the terms of the binomial, keep track to make sure that you have them all included in your multiplication. The FOIL method, it's really the first one that I showed you, but FOIL stands for first, outside, inside, and then last. And the reason I don't really care for this is because it only works for two binomials, but the concept really goes into multiplying any polynomials together. So this only works for binomials. And what do we mean by first, outside, inside, last? Well, in this example here, let me write it a little bit bigger. X minus 3 times x minus 6, we have 4 terms. What do we mean by first? Well, each of these terms, each of those x's are first in their given binomial, right? So those are the first terms. Outside would be these two. So this one is also outside, first outside. This one's outside because it's on the outside of the two binomials of the expression written together. Let's see. These two would be inside because they're inside the outside ones. I don't know how else to say that. Those two would be inside. And then finally, these two are last because they come last in their given binomials. But it's really the same as the first one. So if I multiply first, I get those two. X and x is x squared. Outside would be the x and the negative 6, so negative 6x. Inside, the negative 3 and the x, negative 3x. Last would be negative 3 times negative 6, positive 18. So x squared minus 9x plus 18. Okay. So I'm not going to do the other second example here because this is really just a chance for us to talk about what FOIL is. I don't use this very much, but you may run into it in future classes. Next year in high school, your teachers might say something about FOIL it, and then at least you'll know what it is. Okay? And then finally, multiplying a binomial and a trinomial. I'm going to write this a little bit bigger over here. We have the binomial x plus 5 multiplied by the trinomial x squared minus 3x minus 2. X squared minus 3x minus 2. Well, the same kind of general rule goes for what we're doing on the other examples, which is essentially multiplying this x by every term, which is in this case now 3 terms on the other side. So x times x squared gets me x cubed. X times negative 3x, negative 3x squared. X times negative 2, negative 2x. And then I do the same for the 5. 5 times x squared, 5x squared. 5 times negative 3x, negative 15x. 5 times negative 2, negative 10. And then collecting like terms, you got to be a little bit more careful. X cubed, that's going to be our leading term. Negative 3x squared and positive 5x squared would be 2x squared. Collecting like terms. Negative 2x and negative 15x would be negative 17x. And that leaves the constant negative 10 by itself at the end. Okay. So remember, it's not enough just to write down the problem and the answer. You should be showing, again, what do we have here? 6 partial products. I multiplied 6 times before I added together. 6 partial products. Okay, that's it for this video. We'll practice this more in class. This just requires a lot of practice to get comfortable with it, but it's not really too bad. See you in class. Thanks a lot. Have a great rest of your day. Bye-bye.